So I'd like to welcome our guest facilitator, Eric Seymour. He's the warning coordination meteorologist in Wakefield, and I'll turn it over to him.
All right, good morning, everyone. I wanted to spend a few minutes this morning with you guys talking about the hurricane season. We're kind of about the midway point right now. Lee's gotten a lot of headlines over the last couple of days. And then, of course, we dealt with Idalia back at the end of August and early part of September. So, we've had a couple systems. So we're going to take a look at kind of what's going on with the season right now, what's left, what potentially could occur still for the rest of the season. And then look at some of the different products and make sure we all have a good understanding of what information we're trying to convey with those products when we're using them to make decisions. So that you can kind of see that's kind of what we're going to look at. We'll look at the review of the season so far, some of those products, and I also want to share a few products that our office locally does that are available for you guys to use as well. So these kind of augment what's coming from the Hurricane Center. So just to give you a little bit more information. All right, so the outlook for the 2023 season, initially, when we started off, we started with Arlene back in early June. It was the first one, like the second or third day of the season in June, formed in the Northeast Gulf of Mexico, and actually moved south toward Cuba before it dissipated. So was only out there for about 2 or 3 days. And we've moved through Brett, Cindy, Don, all the way down to Lee, and actually Margot is actually out in the central Atlantic right now. Is also a hurricane out there. So, but not going to impact any land. As a matter of fact, it'll eventually get picked up later this weekend, early next week by the remnants of Lee as it heads off through the North Atlantic. So, right now that's 13 storms. Nigel will be the next one, and right now the Hurricane Center is watching another area disturbed weather that could end up becoming Nigel. So. That would be 14 storms. And if we look at the kind of the outlook, this was the update that came on August the 10th. They actually updated the forecast from a near normal year, which would have been around 14 storms, to an above normal year. So Nigel would make 14, that kind of get us right to about average. So we'll see kind of how the rest of the season plays out, how much farther above the current 13 that we have as far as named storms. Now, from impacts, basically we've had 2 systems that have made landfall in the continental U.S. You had Idalia that made landfall in the Big Bend of Florida. And then we had earlier in August, we had Harold make landfall in southern Texas. So, and it made landfall as a tropical storm. So a lot of rain with it, but overall not too many impacts from Harold as it came inland. So, outside of that, you can see most of the rest of the activity in the Atlantic Basin really has been kind of out in the central and eastern part of the Atlantic. And most of the storms have recurved and really not made too much of an impact on any landmass. So we'll see how Lee goes over the next couple of days, how much impact it has in the Northeast U.S. And we'll look at some of the graphics for those. So in a couple of minutes. So kind of a couple of things that kind of have been driving the tropical environment this year have been water temperatures. The sea surface temperatures, generally speaking, we need to have water temperatures that are at least 80 degrees Fahrenheit or about 26 degrees Celsius, kind of as a guide for where we tend to see tropical activity develop and be able to sustain itself and continue to grow. You can see right now most of the tropical basin south of 30 North is warm enough to support tropical activity. And that's kind of generally where we've seen a lot of that activity is kind of in the central Atlantic into the, kind of the middle part there. So haven't had much in the Gulf of Mexico. So it's still fairly uniform in temperatures, kind of in the upper 80s to around 90 degrees. So it's still fairly warm there. The graphic that's on the right here is actually the anomaly. So how much warmer than normal is it? And earlier in the summer, before we started seeing a lot of these tropical systems in mid-August, most of the basin was really pushing around 2 degrees above normal. Some of that has gone down a little bit in respect of having some of these tropical systems go through, because as the tropical systems go through, they use the heat content to help drive their storms, but you also get a lot of wave action. You're getting a lot of significant waves out there. it helps turn the oceans over, and it brings some of that cooler water that's underneath to the surface. So it helps to start cooling the waters down. And you can see that specifically kind of north and west of Bermuda, where that's the one area we actually show some below normal water temperatures. And that's where Franklin and Idalia have already gone through over the last few weeks. And Lee's going to be tracking over some of that same water here coming up in the next day or so. So that actually may end up helping to lead Lee to weaken a little bit because it doesn't quite have the heat content there. And you can also see a pretty good depiction of the Gulf Stream as it comes off the coast of North Carolina and then starts to head eastward in the Atlantic. So once Lee gets north of that Gulf Stream, so once it gets north of about 40 north this weekend as it makes its way up toward New England, and it starts to move over cooler waters, you will see the hurricane itself begin to weaken as well. The water temperatures just won't support the strong thunderstorm activity that's required to keep the system growing. So, kind of gives you a little bit of an idea, but this has kind of been the driving factor of why they updated the forecast in August to be above normal instead of near normal. It's just because of the sea surface temperatures being so warm down there that anything that did form was going to have the ability to be able to develop and grow. One of the negatives to the hurricane season has been the development of El Nino in the central Atlantic. You can see these are the sea surface temperature anomalies. When the water is above normal, it's El Nino. When it's below normal, it's La Nina. And they have a big effect on the wind flow patterns across the northern hemisphere. So you can see this pattern as we've moved through from June through into September, how the warmer than normal waters in the Central Pacific have really been developing and taking off. So we are definitely in the middle of a strong developing El Nino, and we'll be dealing with that for the winter months as well. The big difference I think you can see in this graphic really tries to describe it is where convection is going to form and be able to grow and develop. In La Nina, which we've had the last couple of years, you can see you get much better convection across portions of the Caribbean and all the islands down there, Cuba, Haiti, all those areas. That area tends to be very favorable in La Ninas for thunderstorm activities to grow and develop and things of that nature. If you remember the graphic we looked at on where all the different tracks of the storms are, very few storms are developing in the Caribbean in this year. It's all been more in the Eastern Atlantic and then heading more up into the Central Atlantic. Well, this graphic kind of helps explain why, because we're not seeing that plentiful region for development of convection and thunderstorm activity and things of that nature. We saw that in La Nina. In El Nino, we don't see that. We tend to see sinking motion in there. So we're not seeing development in that part of the basin. We're seeing it more to the east. So it is taking advantage of the warmer than water normal sea surface temperatures, but we're not getting development in the Caribbean. And without that, I think that's one reason why we're not seeing quite as much activity make any kind of landfall in the continental U.S. Most things that are forming out in the ocean are able to recurve, head back to the east before making landfall. So one kind of benefit of El Nino developing this year. Okay, so from a overall standpoint, when we look at the entire hurricane season, September 10th is typically the peak of the hurricane season. So we've just gone beyond that. We're just now kind of on the downhill side. So we've kind of hit that peak and moving down. We have had quite a bit of activity in here, though, between kind of the last week of August and the first week and a half of September. The bulk of the storms that we've seen this year have formed in here. I think we've had of the 13 named storms, 8 of them have formed in this time period. So this has been a very active period, and climatologically, this is when it should be active. This is when we expect to see more storms developing. So, but we still got a pretty good chunk to go, about another month or so to get through mid-October. So from now through mid-October, we still have a pretty good opportunity to see tropical systems develop. And then once we get beyond that, the impact really starts to wane as we head into the end of October and into the first part of November. Not that we can't have storms, because I know several years ago, I think 2020, we had 2 systems that made Gulf Coast landfalls that impacted Virginia in the kind of the November 10th to 15th time period. So it can happen. It's not that we're completely at it was, but climatology says the threat really does start to diminish at that point. All right, so let's talk about some of the Hurricane Center products. So if we do have something form begin to become a threat for us, make sure we understand what these products are trying to convey and what information we really want to make sure we get from these. So the first one is the cone graphic, and this is the one that gets a lot of play. A lot of people see this, and sometimes it's in the flavor that you're seeing here from the Hurricane Center. Other times when you're looking at the maybe your local TV meteorologist, things like that, they've got a slightly different view of it, but the cone itself is the same. And so what you're seeing on this graphic, there's several things we can take away from it. One, we can take away where the center of the storm is supposed to be. You can see the placement of the dots of H and then dots of S over the next next 3 days or so with this storm. So you can see the track. The cone tells you where the center could be 2/3 of the time. The other things we can pick up here is we can pick up the size of the wind field of the storm. So the orange area is the area of tropical storm force winds, and the red area is the area of hurricane force winds. So it gives us an idea of the size. And you can see based upon how the cone is, the size of the winds are much larger than what the cone actually is. So, we don't want to get too caught up thinking that if I'm in the cone, I got to worry. If I'm not, I don't. So we can see here that's not the case. The other thing we can pick up off of this graphic is we can see where all the watches and warnings are. So right now, if you're on Cape Cod, you're under a tropical storm warning. So that was one of the things that changed with the current forecast. It just came out 11 o'clock. So that area is expecting to see winds in excess of 39 miles an hour up to 73 miles an hour. The areas that are in yellow are for tropical storm watches, and the areas in pink are hurricane watches. So right now, they haven't gone to the warning phase. We're still a little bit too far out in time-wise of when impacts will occur. But I would expect to see probably at 5 o'clock that some of these watches that are still left in place will probably be converted over to warnings at that point in time. All right, so the cone itself, how do we generate the cone? Okay, so what they do with the cone is they take the forecast for the last 5 years, and at every time step that they're forecasting, they're making a forecast at the 12-hour, 24, 36, 48, 60, 72, 96, and 120 hours. So if the hurricane is going to be out there through all 5 days, they make a forecast at each of those time steps. Now, what they do is they go back and they look at all the forecasts they made at each time step for the last 5 years, and they find out what the error was in their forecast. So, they probably have, thousands of forecasts that they're looking at, thousands of points over those 5-year period. And they're taking everyone at each of those time steps, averaging the error together, and then finding out what would be 2/3 of that error. So if the average error, and I'm just going to use for an example, this isn't what the values actually are, but I'm just going to use for an example. If the average forecast is 60, average error is 60 nautical miles at that time step, 2/3 of that would be 40 nautical miles. So then they'll use a 40-mile radius around that point to come up with what the error is. So that would tell them within 2/3 of that time, the center of the system would be within 40 nautical miles of that point at that time. So we make all these different circles, and then we connect the outer edge of the circles to make the large cone. So you're using those average errors over a 5-year period to come up with it. Now, remember, we're only doing that for the forecast for 2/3 of that error, not the whole error in whole average error. So that means really about when you start looking at statistically, 2/3 of the time will be in the cone or on the cone. 1/3 of the time we're going to be outside of the cone. So from a planning perspective, especially when we're looking at 4 or 5 days out, your error out here is sometimes usually 150, maybe up to 200 miles from where the center is forecast. So, and we're only in it 2/3 of the time. So it means 1/3 of the time we're going to be outside of that. So in the case here, like this was Florence's forecast 5 days out. They actually ended up having a very good forecast. This forecast actually verified almost dead on. I think at 8 o'clock on that Friday morning, it was actually making landfall right near Wilmington. So, the forecast overall was pretty good. But let's say, for instance, it had turned farther north and made landfall up, closer to Virginia Beach. Well, that's within the cone. That's not that far away. So you could sit there and say, the forecast again wasn't bad. We were within the cone. Well, it could have very easily just as been as far north as coming in around Chincoteague, which is just outside of the error cone. So at 5 days out, we still have to plan for those storms that are going to end up being outside the cone, that fall outside of that, kind of that 67th percentile, or that 2/3 area that we're looking at. So again, keeping in mind from a planning purpose, that's why we kind of have to remember that 1/3 of the time, the center of the storm really will end up outside of the cone. Okay. One of the good things is you can see you got the last 10 years from 2003 to 2023. You can see how the error cone has shrunk, which tells us, we're getting better. Our forecasting are getting better. The tools we have are better. And as a result, the confidence should be better in the forecast that's coming. A lot of times when you're dealing with these much stronger systems, the forecast and models usually tend to do a better job. The ones that we really see the model struggling on are actually some of the tropical storms that are a little bit weaker, that aren't really well defined, things of that nature. That's really when we really tend to struggle, because the models aren't exactly sure where the system is when it's trying to make a forecast. So, knowing exactly where it is, the size of it, things of that nature, the strength that really helps. So usually, like I said, the more defined systems, the stronger systems, usually the forecast tends to be a little bit better. And I can use Lee for an example here. The models have been pretty spot on with this for about 10 days as far as where this thing was going to go. There's a little deviation here and there, but overall, it had the idea of it moving northwest for about 5 or 6 days until it got to about Wednesday, to about yesterday, and then it would start making the turn and head north. So, these more defined systems usually tend to be better. So, but when you're averaging out over the whole thing, over the entire time step, you can see how we really have improved the forecasting overall. All right, so a couple things to remember about the cone graphic, just to reiterate that the cone itself doesn't relay anything about impacts. So it doesn't tell you what areas may see strong winds, gusty wind, heavy rainfall, surge. None of those things are included with the cone. The cone's just giving you an idea of where the center of the storm is going to be. I heard a couple stories last year from Ian, from folks down in Florida, where one lady said she lived in Tampa, saw she wasn't in the cone, or she was in the cone, so she needed to move. So she moved down to down towards Sarasota and those areas, and actually ended up in worse condition because she moved south into where the track of the system actually ended up turning. And that area was still in a hurricane warning and an evacuation zone, but because she wasn't in the swath, she didn't think it was being impacted down there. So the cone does not give us any indication of impacts. And you can see in this graphic here from Idalia, right before it made landfall, the cone was pretty narrow coming in. It was going to make landfall somewhere in the Big Bend, but the wind field was large enough that you're affecting areas down to Tampa. And we know the kind of the best storm surge was actually over towards Cedar Key. So, and Cedar Key was not in the swath at that point in the cone. So, keep in mind that where that cone is doesn't really relate impacts in any way, shape, or form. All right, so some of the other graphics that you'll see some of these wind speed probability graphics, and we'll go over how those are made here in a second, but we have them for tropical storm, 50 knot, and then also hurricane force. So you get an idea of what the probability is of seeing those kind of winds, and it's over the full 5-day period. So in this case, the graphics that we have here, these are from this morning, generated this morning for Lee. So anywhere between now and next Tuesday, the probability of seeing tropical storm force winds is actually pretty high. It's up to around 50-60% in parts of Maine. So, you've got a pretty good threat of seeing tropical storm force winds. And, it looks like the hurricane force tropical storm force winds, and maybe tropical storm force winds are getting up to about 50 knots if I'm in southeastern Maine. The one thing it doesn't tell you, because it's over 5 days, it doesn't tell you when I should be planning for, and we'll talk about that here in a second. So if we're looking at how these wind speed graphics are created, they run 1,000 different iterations of the model to get an idea of where the storm's going to go and what the impacts would be, the speed and everything else. And then what it does is it takes, based upon all these different tracks, it'll look at a spot and say, how many times does that spot see these type of winds? Doesn't worry about the timing on it, just how many times does it see it? So in this case, this example here we used, New York City, 590 times out of 1,000 scenarios, they saw tropical storm force winds in this scenario from this storm coming northward. So We take 590, we divide it by 1,000, it gives us a 59% chance of seeing tropical storm force winds over that 5-day period. So that's kind of how they're creating it. They're running these simulations using computer models, and each model runs just slightly different. Things are, some differences within the model as far as, how the storm forms, how it may move, things of that nature. So they've got all these different runs that they're going and coming up with this 1,000 model run scenario to come up with the number of times that it reaches it. But how can we start to put some timing on it? Well, we've got some of these other graphics here as well. There's 2 graphics that help with timing. Most likely arrival time, which is the kind of the 50% time. It's the time period when we look at it, we say, this is, 50% of the time it would get here earlier, 50% of the time it gets here later. This is the time period by which you need to have any preparations done if you're going to be having something make landfall. So in this case right here, you can see the tropical storm force winds. If I'm in down East Maine, I'm looking at somewhere where I may see 50 or 60% chance of seeing those winds. From a time period standpoint, I need to be looking at from a, most likely arrival time is sometime Saturday afternoon. That's when I expect to see those winds arrive. So that's kind of what the most likely graphic is. It's that 50-50 time period. And if we looked at the earliest reasonable graphic, okay, the earliest reasonable graphic is, 10% of the, only 10% of the time, 10% of the runs does it get here before that time period. So it kind of gives us that time period where, if I can't have any risk at all of having any kind of those winds for, whatever property, things like that, I've got to have it all done before any chance that happens. That's that earliest reasonable graphic. And, that would probably be, in this case, it's probably going to bump it up probably closer to 8 a.m. Saturday morning. You'll probably see about a 6 to 10 hour bump based upon, kind of how the storm is moving at this point. So those are your arrival graphics. So you can put the probability of seeing certain wind values along with those timing graphics to really kind of help you be able to paint the picture and make some decisions. The storm surge watch warning graphic is there because storm surge is no longer tied to the category. For a long time, we tied storm surge in with the category of the storm, 1, 2, 3, 4, and 5. Well, several years ago, the storm surge got pulled out because we realized that storm surge doesn't necessarily correlate always to this, whatever the wind category of the storm is. A lot of times it can be very vastly different. So we've created this graphic here, which has its own watch warning function with it. So at 48 hours out, you would see some, the watch would be issued for storm surge if we're thinking, basically 3 foot above ground level in your normal, tidal zones that would see flooding, things of that nature. If we get above 3 foot or more, that's where the warning goes into effect. If we get within 36 hours, we change the watch to a warning at that point in time. So that's kind of how that storm surge watch warning graphic. And some of the products that come out with that, this is one you may see as a potential storm zone, storm surge flooding area. So this graphically shows you what the inundation would look like. And that is a very valuable tool to help, from a planning perspective, as you can see where we expect water going. So in this case, this was down toward Charleston, South Carolina, and it gives you some idea there of where the water would go. You also have this graphic here, which is a little bit more general, kind of gives you the entire coastline, gives you an idea of what the ranges are in those particular areas. So those are available as well. And again, all these storm surge graphics don't really show up to where you can see them until a watch is issued. Otherwise, you will not see these graphics. So if we're 5-6 days out, you're not going to see these graphics. They're not available. All right, the last couple of things we're looking at, we got the rainfall potential graphics. So the Weather Prediction Center produces the kind of the storm total graphic. They also produce the excessive rainfall. So this gives us an idea of where flash flooding is potential to happen. So you've got those graphics. And then the local forecast office is going to take this QPF graphic, and they're actually going to go in and fine tune it a little bit more for your local area. So when you start looking at like the graphics for our office, you can see those a little bit more detail oriented. The 7-day outlook used to be a 5-day outlook. It's now a 7-day outlook. So you're going to see maybe a little bit larger area of potential development is one of those things that'll occur with that. But don't take this as a track or a path, the area that's here. It's actually just marking the area somewhere in here in the next 7 days. We think development is possible or likely, and you can see what those percentages are down here at the bottom. Getting it, I got two more graphics here. These are the local graphics that we produce, the hurricane threat impact graphics. So if we do have a storm, there's 4 graphics that we create: a wind threat, storm surge, heavy rainfall or flooding rainfall, and then tornado threat. So all these graphics are available. They're all on our webpage, what the local office creates those. And you can see what the categories are. So it gives you an idea of what potential impacts you could be seeing, based upon the storm that's there. In this case, this was, I think this was from Irma. These graphics here were created from Irma in 2017. So you had a major hurricane making landfall in Southwest Florida. So you can see where the extreme impact for winds was and things of that nature. So these graphics are created by the local office, and we coordinate with our neighbors to make sure the graphics, that we're all thinking this on the same page and giving the kind of the same message. So you're not seeing somebody put an extreme right next to a medium. That would not really look good. So we are coordinating that to make sure our thoughts are similar. And then the last thing, this is the AKQ tidal forecast. So anybody that's down near the coast, even all the way up into the James River, we're coming up on the 20-year anniversary of Hurricane Isabel. Isabel had storm surge and made it all the way into the city of Richmond up the James River. It got up into the moderate flood category just on the storm surge alone. And then when we had the rainfall flooding come in about a day and a half later, it went right back up. It went down and went right back up into moderate. So, there's a lot of really good information here for tidal areas, being able to see the different gauges, what the forecast is, and things of that nature. So again, these things are all right there. So, and I know we're getting close to the end of our time here, so we can take any questions you guys might have.